Okay, Chapter 14, Review for Test. Now, the first question has to do with the index of refraction when we're going from one medium to another, because refract means to bend. So light bends when the speed changes, and we know the fastest possible speed for light is in a vacuum, 3.0 times 10 to the 8 meters per second. So as the medium gets more dense, the light ray is going to slow down. So I think it was last year that I thought about a way to memorize that so you don't forget, because people always get confused. Now, in English class, there's a certain format you always have to write your essays in. What is that format called? MLA. Can you remember MLA? Can you remember MLA up? Sounds like a cheer, right? MLA up. Okay? So let me show you this and what it means. So this is the first page of our notes. So you're going to remember MLA up. That's the one thing you're going to memorize. So let me tell you what it means. We're going to say that L stands for less dense, right? And M stands for more dense. So MLA is going to be when you go from a more dense to a less dense, it moves away from the normal, and it's going to speed up. So what you're going to memorize is MLA up. More dense, less dense, it moves away, and it speeds up. So I think everybody can remember MLA up, right? And then the reverse of that is LMT. So when you go from a more dense to a less dense, you bend away from the normal, and it's going to speed up. So you're going to remember MLA up, and that's going to be something very easy for you to remember, MLA up. And then if you go from a less dense to a more dense, it's going to bend towards the normal, and it's going to slow down. So this is what's going to help you, because this is one of those things where you have to memorize. Does it bend towards or away? Does it speed up or does it slow down? So this is what we're going to memorize, MLA up. More dense to less dense, it's going to bend away from the normal, and it's going to speed up. That's what the up means. Okay? So MLA up. All right, now let's go on to the review sheet. So question number 1 says, the diagram below shows light ray R entering air from water. So we always need to know where are we going from or to. So we're going from water. So we're going from water to air. So in this particular case, we're going from water, which is more dense, to air, which is less dense. Okay, so remember, what do we remember? We remember MLA up, and then the opposite would be LMT down. Again, this is what we're going to memorize. So you just have to memorize the MLA up. So in this case, we're going from a more dense to a less dense. So what we're going to do is we're going to bend away from the normal. So let's look at this. First of all, you're going to cross off choice B, because choice B is the light ray of light going in a straight line. So right away, you're going to say, I know B's not right. D is the normal, so that's not right. So the answer is either A or C. So it's either going to bend. Remember, this is the normal. That's towards the normal. This is away from the normal. So this one is going to bend away from the normal because more dense to less dense is away. So the choice here is A. MLA up. We can all remember that, right? All right, number 2. When a light ray passes from medium 1 to medium 2, its speed decreases. Which arrow best represents the path in medium 2? So because the speed decreases, then it's going to bend towards the normal. So again, I can eliminate the totally wrong choices. Like this is totally wrong and this is totally wrong. So it's either bending towards or away. So the answer is going to be 2B. Number 3. which characteristic of a wave changes as the wave travels across a boundary between two different media? Okay? So one of the things that we know is that we know V is equal to F lambda. Okay? And if I'm going from one medium to another, we know the speed is going to change, right? So if this changes, the wavelength is going to change, so whatever is going to stay the same is going to be the frequency. The frequency is what stays the same, and what changes is we know the speed changes. I said that right away. The frequency stays the same. So as we go from one medium to another, we know that the speed changes, and that has to do with the physical properties of the medium. All right, next one, number 4. The diagram below shows a ray of light passing from medium X into air. So this is medium X, and it's going from medium X into air. And if you have a difficult time to seeing it, this is the boundary between the two medium, and that's the normal. So now the question says, what is the absolute index of refraction? So this is where we're going to use Snell's law. Snell's law says N1, and I'll call this X. So Nx sine of 30 degrees is equal to N sine of 60 degrees. Snell's law, the basic equation is Ni sine of theta I is equal to Nr sine of theta R. Okay? So in this case, we're going from X to air. I know the index of refraction of air is 1, so I'm going to rearrange this equation and say Nx is equal to 1 times the sine of 60 over the sine of 30 degrees. So I put that in my calculator, sine of 60 times 1 divided by the sine of 30, and this comes out to be, so let's look at the calculator. Put that right here. So I'm going to press 60 sine, which is 0.866, times 1 equals, and I didn't have to do times 1, I'm just showing you what buttons you would press if it wasn't 1, divided by 30 sine, which is 0.5 equals, so it comes out to be 1.7, which is choice C. And that's how you do it on the calculator. Number 5, if the speed of light in a medium is 1.5 times 10 to the 8 meters per second, so that's the velocity, the index of refraction in that medium is, so we're going to use the equation N is equal to C over V. So the speed of light in a vacuum, 3.0 times 10 to the 8 meters per second, divided by 1.5 times 10 to the 8 meters per second. Now guess what? I can do that in my head because the exponents are the same. 3 divided by 1.5 is 2. Now I could do it on my calculator, but again, even if I do it on my calculator, that's a calculation I can do in my head, so I'm going to check it to make sure I don't make a mistake. All right, number 6. When a wave enters a medium of higher refractive index, its velocity is going to decrease. We know that if n is greater, it's going to slow down. And you can look at the equation again, N is equal to C over V. Remember, C is equal to, well, we just know that from the other, the MLA up and stuff. So if the N is greater, it's going to slow down. So if it goes from, going back here, from a less dense to a more dense, it's going to slow down. As a ray of monochromatic light, so remember that's only one wavelength, enters a block of flint glass from air. So it's going from air to glass. So it's going from a less dense to a more dense. So when it goes from a less dense to a more dense, let's look up here. Less dense to more dense, it's going to slow down. So that's why that MLA up, that is something you definitely need to know for the test, because how many questions have we had on that so far? That's 4. Number 8, a beam of monochromatic red light passes obliquely from air into water. So it's going from air to water. So we know it's going to slow down. We know the velocity is going to change. So which characteristic does not change? We know that the frequency does not change. So these two questions are basically the same. What stays the same is the frequency. Number 9, a diverging concave lens can form images that are virtual only. A. Number 10, an object is located 1.5 meters, that's DO, from a converging lens with a focal length. You see, as I'm going along, I'm writing down my given. How far? So now I have DO, I have F, and I want to find DI. So I'm going to use my same lens equation. 1 over F is 1 over DI plus 1 over DO. I'm going to rearrange the equation. DI is equal to DOF minus DO minus F. So it's going to be 0.15 times 0.1 over 0.15 minus 0.1. So when I do all the math, this comes out to be 0.3. And that would be choice D. So already done with the front. Go to the second page. Alright, so we have different types of lenses here. It says, which diagram most accurately represents the behavior of light passing through a glass lens? Now, here, the arrows like this shows where the light is coming from. Now, let's look at this choice. This type of a lens is a diverging lens. So when the light rays go through it, they're going to spread apart. So this is wrong. Okay? When light rays go through this type of lens, again, they're supposed to come together. So these are just wrong. So I see this is the type that light rays go through and then they diverge, which means to spread apart. Number 12. A converging lens is used to produce an image of an object. The object distance is twice the image distance. If the object is 0.5 meters tall, the height of the image is. So first of all, this is a converging lens. We know that in a converging lens that looks like this, the rays of light have to come together. All right. Now my equation for magnification is HI over HO is negative DI over DO. Okay? Now what they tell us is that it says that if the object is so let's see. If the object is 0.05 meters tall, so 0.05 meters tall, the height of the images, the object distance is twice the image distance. So this is key here. We know that the object distance is DO, and that's equal to twice the image distance. So DO is equal to 2DI. So this is extremely important. So when I look at my equation here, I know that DO is 2DI. So in this equation, instead of having HI over HO is equal to negative DI over DO, this is going to be 1 divided by 2 because DO is twice DI. So this is the hard part here. So HI is equal to negative 1/2. And now when I do this equation, now I would know, I rearrange this and say HI over HO, again, is equal to negative 1/2, and I cross multiply, so I end up getting HI is equal to 0.025 meters. And it doesn't ask you, if it's inverted or not. They just want to know what that is, the magnitude of it. So I would say 2 times HI is equal to HO. All right, number 13. A convex converging lens can form images that are either real or virtual. This is the key there, or. Number 14, you have to do a ray diagram. Now, we're going to have an FRQ where you have to do this. So how do you do this? Well, you're going to have to use your ruler. And the first thing you're always going to do is you're going to start at the top of the object. And you're going to go through that middle point. Like this. Then you're going to go from the top of the object to the middle of the lens. And then once you get to the middle part of the lens, then you go through F. Where the two rays meet, that's where, so don't forget to draw your arrow here, because on the FRQ, if you don't draw your arrow, you're going to lose points. So I see that this is going to be real and enlarged, and it's inverted because it's upside down. So the choice there is A. And then the last choice is that's it. Oh no, there's another question on here. Was this on yours? No, that was a mistake. So I just printed that. That's not part of the thing. I whited it out on your copy. And that's it. That's it for the review sheet. And then we still have to do the problems on the back.